Click the bell icon to get latest videos from Ekeeda.
Hello friends, in today's video we are going to see two more gates, that is nothing but NAND and NOR gate, which are also called as universal gate, their truth table, logical symbol and their representation. So let's begin with the topic. The first gate that we are going to consider is nothing but NAND gate. The NAND, as its name indicates, it's a series combination of AND and NOT gate. So we can say NAND is nothing but NOT plus AND gate. The output of NAND gate is nothing but a complementary version of AND gate. We know that in case of AND gate, if any one of the input is low, the output goes low. If both the inputs are high, then only the output becomes high. As NAND gate is complementary version of AND gate, therefore in case of NAND gate, if any one of the input is low, the output goes high, and if both the inputs are high, the output becomes low only. Now let's see how the NAND gate is represented symbolically. So the symbol of NAND gate is two inputs A and B, and with bubble, which indicates inverted version, that means NOT. So this is what the symbol of NAND gates looks like. If we draw equivalent circuit, then the circuit becomes, so the two inputs A and B, and the output of AND is given to the inverter or NOT gate, which provides output Y. The logical operator that is used for representation of the NAND gate is nothing but a dot operator along with a bar operator. So the logical equation for NAND gate is given by Y is equals to A into B, which represents equation of AND gate, and bar, which is nothing but inverted version, that is NOT gate. So let's see the truth table of NAND gate. As we are having two inputs A and B, therefore the total number of combination becomes 4. The output Y equals to A into B bar. As NAND is inverted version of AND, so 0 0 becomes 1, 1 0 becomes 1, 1 1 becomes 1, 1 0 becomes 1, and 1 1 becomes 0. So if we look at the truth table properly, we will come to know that the truth table is complementary version of AND gate truth table. Now the NAND gate is also called as universal gate because all the three basic gates, that means AND, OR and NOT gate, can be represented by using NAND gate. The NAND gates are used in most of the digital circuit, as they can also be used to perform a function of AND gate, function as a NOT gate, and function as a OR gate. Now let's see how we will obtain operation of AND, NOT and OR by using a NAND gate only. Now first we will see how output of AND gate can be obtained by using NAND gate. So for that we consider two input signals A and B, which is first given to the NAND gate. So we will get signal as A into B bar. Now the same signal is applied to second NAND gate. So we will get Y is equals to A into B. Here we are using A into B bar as input to the second NAND gate. So the output becomes A into B, which is nothing but output of AND gate. Now let's see how representation of OR can be done by using NAND gate. So for OR gate, we'll use signal A is given to first AND gate, signal B is given to second NAND gate, and output of this is given to third NAND gate. So we will get A plus B as a output. Now the NOT gate representation, if we apply same input signal, we are using two inputs A and B here, but we are giving same signal to the two inputs. So I'm representing A only as A and B. So we'll get y is equals to A bar. So this is how we can represent a function of AND, NOT and OR gate by using NAND gate. So that's why the NAND gate is called as universal gate. Now let's see the another type of gate, that is nothing but NOR gate. As we saw, NAND is a combination of AND and NOT gate. Similarly, NOR is a combination of NOT and OR gate. So therefore we can say NOR is nothing but OR plus NOT gate. So similar to NAND gate, in NOR gate also we are getting complemented version of output of OR gate, and the symbol of NOR gate is given by two inputs A and B apply to the OR gate. Bubble represents NOT, so we will get Y signal at the output. Here the logical operator used here plus along with the bar line. So the logical equation becomes y is equals to A plus B, which represents equation of OR, and bar on that represents equation of NOT. So we can say the logical symbol is nothing but two signals AB. The output is A plus B, which is given to NOT gate. So we will get A plus B bar, which is equation of NOR gate. Now let's see the truth table of NOR gate. As we are having two inputs, four combinations. Now in case of OR, if any one of the input is high, the output becomes high. If both the inputs are low, the output becomes low. But NOR is an inverted version of OR. Therefore, if any one of the input goes high, the output goes low. So the truth table becomes 0, 0 becomes 1, and for remaining all combination, the output remains 0. Similar to NAND gate, NOR gate is also called as universal gate because AND, OR and NOT gate can be implemented by using NOR gate. Now let's see their implementation. So AND using NOR gate, input A is given to first NOR gate, input B is given to second NOR gate. So their output is now given to third NOR gate. So this will give you the function as similar to the AND gate. Now let's see representation of NOT gate by using NOR gate. If the same input signal is applied to both the inputs of NOR gate, we will get signal Y as output of NOT gate. Now the third representation is nothing but representation of OR using NOR. Input A, and here the input is B. Now the same input A is given to the second input of second NOR gate, and input B is given to the second input of first NOR gate, and output is given to third NOR gate. So we will get output which is nothing but the output of OR gate only. So this is how we can represent NAND and NOR gate as a universal gate. That means the other basic gates AND, NOT and OR gate can be represented by using NOR and NAND, and therefore they are called as universal gate. AND is nothing but a complementary version of AND gate, and NOR is nothing but the complementary version of OR gate. So I hope you understand these two logic gates along with their truth table and symbol. So thank you very much for watching this video. Stay tuned to Ekeeda, subscribe Ekeeda. Thank you.